Igor Vasilyevich Kurchatov was a Soviet nuclear physicist who was widely known as the director of the Soviet atomic bomb project, along with Georgy Flyorov and Andrei Sakharov. Kurchatov is widely remembered and dubbed as the "father of the Soviet atomic bomb" for his directorial role in the development of the Soviet nuclear program. In a clandestine program during World War II formed in the wake of the USSR's discovery of the Western Allied efforts to develop nuclear weapons. After 9 years of covert development, the Soviet Union successfully tested its first nuclear weapon, codenamed First Lightning, at the Semipalatinsk Test Range in 1949. In 1954 he was awarded the USSR State Prize in Physics. From 1940 onward, Kurchatov worked on and contributed to the advancement of the nuclear weapons program, and later advocated for the peaceful development of nuclear technology. In 1950, Kurchatov contributed in the development of the hydrogen bomb with Andrei Sakharov, who originated this development is Sakharov's third idea. Other projects completed under Kurchatov included the installation and development of Soviet Union's first particle accelerator, the cyclotron, inauguration and established of the Obninsk nuclear power plant, the world's first nuclear power plant in Obninsk, and the completion and launching of the Lenin, the first nuclear power vessel, under his leadership in 1959. Biography. Kurchatov was born in Simsky Zavod, Ufa Governorate, in the family of a chartered surveyor. He was of Russian ethnicity. After completing Simferopol Gymnasium I, he enrolled at the physics department of the Crimea State University, earning his doctorate degree in physics from there, under the supervision of Abram Fedorovich. Kurchatov also studied at the Polytechnical Institute in Petrograd, where he earned his degrees in naval engineering. After studying physics and naval engineering, Kurchatov was a research assistant at the Faculty of Physics of the IOF Physico-Technical Institute in Baku, and later he researched under Drive Abram Fedorovich at the Physico-Technical Institute on various problems connected with radioactivity. After working in a variety of research laboratories and the Azerbaijan Polytechnic Institute in Baku for a year, he came to the Leningrad Institute for Physics and Technology in 1925. Kurchatov's talent for experimenting and organization was recognized there. His early work was consumed with physics of crystals like dielectric and ferroelectric materials. Kurchatov felt at home with these studies. One of his important results was the discovery of ferroelectric properties of Seniet salt. This discovery earned a degree of Doctor of Physics and Mathematics for him. He was awarded this degree without a dissertation in 1934. In 1932, he received funding for his own nuclear science research team, which built the Soviet Union's first cyclotron particle accelerator in 1939. Academic research. Between 1931 and 1934 he worked in the physical department of the Radium Institute, which was headed by Vitaly Klopin, where Kurchatov was researching as a senior scientist and took part in the creation of the Europe's first cyclotron. Then to 1943 he worked at the IOF Institute with Anatoly Petrovich Alexandrov. In the period they devised a method of demagnetizing ships to protect them from German mines, which was in active use through the end of the World War II and afterwards. Kurchatov's laboratory separated from the IOF Institute and moved to Moscow in 1943 for the work on the Soviet atomic bomb project. In 1932, George Gamov and Lev Mysovsky submitted a draft for consideration by the Academic Council of Radium Institute, which was approved by the Soviet government. Klopen, under the guidance and direct participation of Igor Kurchatov, Lev Mysovsky and George Gamov, installed Europe's first cyclotron particle accelerator. Installation was finished in 1937, and the research began to take place on the 21st of September 1939. Kurchatov and his apprentice Georgy Flyorov discovered the basic ideas of the uranium chain reaction and the nuclear reactor concept in the 1939. In 1942, Kurchatov declared that breaking up of kernels in a kilogram of uranium, the energy released must be equal to the explosion of 20,000 tons of trotyle. Quote, "This announcement was practically verified during the atomic bombing of Hiroshima. Scientific experiments and the Soviets' nuclear project. I.V. Kurchatov took part in many scientific experiments through 1933 to 1940. Together with K.D. Sinelnikov, started working on the first proton accelerator at the Ukrainian Institute for Physics and Technology in Kharkov in 1933. Also that year he headed organizing the committee of the First All-Union Conference on the Atomic Nucleus. Kurchatov studied neutron absorption by the nuclei and discovered nuclear isomerism in 2 years later in 1935. Later in 1935 till 1941 he held a seminar on neutron physics while also working with L.V. Mysovsky at the State Radium Institute. In 1937 he investigated resonance neutron absorption by nuclei. Kurchatov started to take part in cyclotron and the development in 1941 jointly with A.I. Alekhanov of the LFTI cyclotron and completed it after World War II. Finally he helped with the discovery of the fission process with O. Hahn and F. Strassman, and then they started an in-depth investigation of uranium. This investigation brought about determining the number of secondary fission neutrons, isolating uranium-235 as a fissile isotope, and finally discovering the spontaneous fission of uranium-238 with G. N. Flyorov and K. A. Potzak. In 1941, the Kurchatov group had joined the ranks of the leading laboratories in Europe and the United States. Then this group started working on chain reactions. Kurchatov was aware of the unique prospects of this new research area and became a member of the Uranium Committee at the Academy of Sciences. V.G. Klopen headed the Uranium Committee at the Academy of Sciences in 1940 and 1941. This committee wrote to the government arguing that they needed to boost uranium research. The Soviets' nuclear project under Kurchatov happened in 3 broad periods. The first phase is from 1935 to 1945, which was the research stage. Then the building of the atomic industry and atomic weapons phase was from 1946 to August 1949. The third stage was the progress of the atomic industry, the creation of hydrogen weapons and the birth of the atomic power generation and the atomic fleet in the Soviet Union from 1950 to 1957. In the research stage, Kurchatov assembled the IOF school's physicists. He assembled his own people to enlist the support of the many familiar schools like of the Rhine and the Institute of Chemical Physics, and the Institute of Physics of the Academy of Sciences to work out physical problems. The physical problems occurring were not being able to obtain nuclear data needed for the start-up of a physical reactor, not being able to find a model of nuclear blast physics, not being able to obtain plutonium in impulse microgram quantities, and lastly, not being able to develop a process for obtaining ultra-pure graphite and metallic uranium. The engineering and industrial phase began in early 1945. This phase can be considered phase of the project. It is said that Kurchatov was caught nodding when a new political situation arose after the atomic bombing of Hiroshima and Nagasaki in August 1945. The second phase began on August 20, 1945, when the State Defense Committee made the decision to set up a special committee, a technical board, and the first main administration to be put in charge of the implementation of the atomic project. Kurchatov and his team were in charge finding out new problems, at the time unknown to scientists. This team acted as research supervisors of major engineering projects, which include the start-up of the first physical reactor, the design, construction and start-up of plants for plutonium production, radiochemical extraction, metallurgy, the development of a physical reactor and an industrial heavy water one, the development of a manufacturing technology of diffusion separation of uranium-235 and uranium-238, the development of industrial mass separators for the electromagnetic separation of isotopes of uranium, and finally, the design, calculation, modeling, construction, and production of the first atomic bomb. During this industrial phase, Kurchatov's team of great engineers, those on construction sites, plant floors, and research laboratories, completed these missions within 3 years in 1942 to 1945. The results of these missions were the solution to the Soviets' nuclear safety. Kurchatov's special outstanding role follows from the USSR Council of Ministers Decree No. 5070 Physics of Atomic Nuclei Volume 66 No. 1-2003-1944 SS Op. Signed by Stalin, concerning the award of atomic project participants, in which Kurchatov's name tops the list, in view of his exceptional service to the Soviet fatherland in the matter of solving the problem of utilization of atomic energy and pursuant to the Council of Ministers Decree No. 626-258 of March 21, 1946, the Council of Ministers of the Union of Soviet Socialist Republics hereby decrees: I-1. Kurchatov Igor Vasilyevich, academician, scientific leader of the atomic reactor and atomic bomb project, to be nominated for the title of Hero of Socialist Labor, to be awarded a bonus of 500,000 rubles, to bestow upon academician I.V. Kurchatov the title of Laureate of the Stalin Prize First Class, to build and transfer to academician I.V. Kurchatov a townhouse and a dacha. The third stage of Kurchatov's work began at the end of 1949. Kurchatov was handing with being a scientific leader of the project to perfect nuclear weapons and create hydrogen weapons, and also being a scientist with a vision to build the foundation for the future advance of nuclear science and engineering. The first group of researchers that helped solve the problem to find a unique design of a nuclear thermonuclear weapon was led by Sakharov in 1953, known as RD6. These group members were as following: I.E. Tamsh S. Belenky, V.L. Ginsburg, A.D. Sakharov, U.A. Romanov, and I.R. Pomeranchuk, V.N. Klimov, N.N. Boglubov, and D.V. Shirkov. Later, a joint team headed by Karatin discovered the basic physical principle of modern thermonuclear weapons, radiation implosion, and carried out a successful test in 1955. The team included Yar Bezeldovich, U. Trotnev and Sakharov. Achieving these scientific discoveries effectively solved the strategic task of securing the Soviet Union's nuclear similarity with the United States. It created a basis to stop the atomic race. Both sides started to lean towards political solutions that could lead to the discontinuance of the nuclear race and cessation of nuclear tests. And Kurchatov was also a necessity to that step. Atom bomb project. In 1941, Germany commenced a large-scale military offensive against the Soviet Union under codename Operation Barbarossa. During this time, Kurchatov was leading the research in nuclear physics and was widely known in the Soviet Academy of Sciences for his wide research. Because of the war with Germany and her allies, the Soviet Union did not undertake any serious initiative to start scientific research into nuclear weapons until 1942. In April 1942, Georgy Flyorov, who would later become a key figure in the nuclear program, addressed a secret letter to Joseph Stalin pointing out that nothing was being published in the physics journals by Americans, British, or even Germans on nuclear fission since the year of its discovery in 1939, and that indeed many of the most prominent physicists in Allied countries seemed not to be publishing at all. This academic silence was highly suspicious, and Flyorov urged Stalin to launch the program with immediate effect, as he believed that other nations were already secretly advancing the programs. In 1943, the NKVD obtained a copy of a secret British report by the Maud Committee concerning the feasibility of atomic weapons, which led Joseph Stalin to order the commencement of a Soviet nuclear program. Stalin turned to the Soviet Academy of Sciences to find the best administrator to lead the program, and as a result, the Soviet Academy of Sciences chose Kurchatov for his wide experience in nuclear physics. IOF recommended Kurchatov to Vyacheslav Molotov, who advised Stalin to appoint Kurchatov as the formal director of the nascent Soviet nuclear program, and the development of Soviet nuclear weapons began in the 1940s. Kurchatov switched his research first to protecting shipping from magnetic mines, and later to tank armor, and finally to nuclear physics. During its formative years, the atomic bomb project remained a relatively low priority until information from spy Klaus Fuchs and later the destruction of Hiroshima and Nagasaki goaded Stalin into action. Stalin ordered Kurchatov to produce a bomb by 1948, and put the ruthless Lavrentiy Beria in direct command of the project. The project took over the town of Sarov in the Gorky Oblast on the Volga, and renamed it ARZAMAS-16. The team was assisted both by public disclosures made by the United States government and by further information supplied by Fuchs, but Kurchatov and Beria insisted his scientists retest everything themselves. Beria in particular would use the intelligence as a third-party check on the conclusions of the teams of scientists. First lightning. On August 29, 1949, Kurchatov's team successfully detonated its initial test device First Lightning at the Semipalatinsk test site. Kurchatov later remarked that his main feeling at the time was one of relief. In the wake of the successful detonation of the U.S.'s first fusion device, codenamed Ivy Mike in 1952, Stalin ordered Soviet scientists to build a comparable device, a program that was launched in 1953. The directors of this project were Vitaly Ginzburg and Andrei Sakharov, who originated this project as Sakharov's third idea. Kurchatov subsequently contributed some of the calculations necessary for the Soviet Union's first hydrogen bomb. Unlike Ginsburg, Sakharov, and Yakov Zeldovich, Kurchatov was only involved in small-scale calculations, applying the basic nuclear weapons principles used in the smaller nuclear weapons that were developed under his directorship. In 1953, the Soviet Union detonated its first thermonuclear device, codenamed Jo-4. While other scientists, such as Ginsburg, Zeldovich and Sakharov earned renown, Kurchatov's contribution was diminished. Other projects. In the late 1950s, Kurchatov advocated against nuclear weapons tests. Among the projects completed under Kurchatov's leadership was the first cyclotron in Moscow, the first atomic reactor in Europe, the first nuclear power plant in the world, the icebreaker Lenin, the world's first nuclear-powered surface ship, and the first nuclear-powered civilian vessel. In January 1949, Kurchatov had been involved in a serious accident which became a catastrophe at Chelyabyinsk 40, in which it is possible that even more people died than at Chernobyl. In an effort to save the uranium load and reduce losses in the production of plutonium, Kurchatov was the first to step into the central hall of the damaged reactor full of radioactive gases. Undoubtedly it was exposure to radiation on at least several occasions that drastically shortened his life. Kurchatov's health sharply declined in his last years. He suffered a stroke in 1954 and died in Moscow of a cardiac embolism on the 7th of February 1960, aged 57. He was cremated and his ashes were buried in the Kremlin Wall necropolis on Red Square. Legacy and honors. During the A-bomb program, Kurchatov swore he would not cut his beard until the program succeeded, and he continued to wear a large beard for the remainder of his life, earning him the nickname the Beard. 2 towns bear his name: Kurchatov Township, the headquarters of the SDS, and Kurchatov near Kursk. The Kurchatov Institute is named in his honor, and bears a large monument dedicated to him at the entrance. The crater Kurchatov on the Moon and the asteroid 2352 Kurchatov are also named after him. Many of his students also enjoyed distinguished careers, among them Andrei Sakharov, Viktor Adamski, Yuri Babev, Yuri Trutnev and Yuri Smirnov, for his part in establishing the Soviet nuclear program, in accordance with State Decree 627-258. Kurchatov was awarded the title of Hero of Socialist Labor, the Stalin Prize First Class, the sum of 500,000 rubles premium in the amount of 500,000 rubles, and a ZIS 110 car, a private house and cottage furnished by the state, a doubling of his salary, and the right to free travel by rail, water and air transport in the USSR. In all, he was 3 times Hero of Socialist Labor, awarded 5 Orders of Lenin, awarded 2 Orders of the Red Banner, awarded the following medals: for victory over Germany, for the defense of Sevastopol, 4 times recipient of the Stalin Prize, recipient of the Lenin Prize. He was also awarded the Gold Medal, Euler Academy of Sciences of the USSR, and the Silver Medal of the World, the Joliot-Curie. In the Transfermium Wars element naming controversy, the USSR's proposed name for element 104 was Kurchatovium, in honor of Kurchatov. Element 104 is now known as Rutherfordium.